So yesterday we completed the profile management, creating a EDM profile, which is required to be assigned to the meter that we have done. Now, the technical side also, our installation data is ready along with the device installation. And on the building front, we have done all the work. So let us say we can go and do the move-in now. And once the move-in is done, we can start the process. Now, let me find out what is the installation number. So go to ES31 Fusion 60. So latest is 250, which is for smart meter. Check 601. Now our MR unit is S1. So based on MR unit, how to do the move-in? Because based on the move-in date, we know the starting of the contract period, and for how many days we want to require the data to be entered. So 219 is a premise and 250 is the installation. Now let us find out one contract account, what we can use. CAA2 for contract account for the company code 6000. It is for collective bill. So we'll use 5301 as the contract account. CA. Now I will do the billing for the month of January. Now, if we do the month of January billing, when the move-in has to happen, our scheduled date of meter reading could be 30th of December or 30th of January. So if I go to scheduling and then schedule record, display, our MR unit is S1. So in 2020, you can say January, 30th of January 2020. So let us say this is the end period for the billing. Now, every day we require 96 results. That means each hour 4 data, for every 50 minutes data 4 numbers, and for 24 hours we require 96 data. So if you do move-in on the first, that means we require that much of data to be entered in the profile for all the 30 days. So instead of that, what I will do, let us say 31st is the scheduled meter reading date, 30th. So I will do move-in on, let us say 28, 29. 28 I will do the move-in. So or 29th will do the move-in. 29 and 30th, 2 days data we will enter in the profile, so that we can test the concept of how the RTP is working. So let us say we are doing the move-in on 29th. So 29th 1 day meter reading and 30th is the another day meter reading. So we will say 30th of January. 30th of January 2020 meter reading date. So 29th move-in. We will do 29th move. So let me go to EC50E. EC50E 2901 2020, and contract account is 5301, and our installation number is 250. So 250 is the installation. I have to just enter the ID for the account determination, that is 60. Now here no meter reading data has to be entered because it's the interval meter, no meter reading data to be entered. Save the move-in. a contract will be prepared. Now a new contract has been prepared. 252 is the contract. Now having created the move-in, we will see whether it is updated in the installation. So move-in has happened on 29th of January. So our billing period is starting from 29th of January 2020. That means we will create our first metering order for the month of January with the scheduled date 30th. So go to EL01 250. Metering reason is 01. So here we are selecting 2020, that is January 30/01 2020. Create the order. So metering order created, billing order created. Now here, based on metering order, we cannot enter any results in the EL01, EL28 because it is only for the conventional meter. But we need the data for billing through the profile. So we have a profile created already. We've assigned it to the meter. So if the profile contains the valid data effectively on 29th and 30th, we can execute the billing, and billing order has been created already. Now I have created some data here for interval data. So starting from midnight to 23:45. Okay, that's the data. So effectively it will come to per day consumption, how much it will come. Let me find out. So it is coming to 30 kilowatt hour for the one day, first day. Let me also create data for the another day. So let us say this is for 29th and this is for 30th. And for 30th, I have taken data slightly more. And for this day, the total consumption will come to it is coming to 33.64. That means first day the total consumption is 30.22 kilowatt hours, second day 33.64. Now first let us find out what is the profile you have created, and for that profile we'll enter the data for each day, that is 29th and 30th. So let me go to EDM and profile management, profile values, change. Now let me select the profile what we have created. we have created our first profile for the division 60. That is 148 is the profile number. Interval data 15 minutes for the meter 1133. Select it. And then selection date, I will give it 29/01/2020. Okay. Although I can enter data for 2 days simultaneously, but I'm selecting for the first time we will select data to be entered for 29th of January 2020. Select here. Now here you can see profile 148 is assigned to register 1 of the meter 1133, which is assigned to the installation 250, and this is the contract, this is a contract account, and this is the BP. So let me select the profile number 148, and then here we have the data to be entered. Now let me copy the data what I have here for 29th. Go to the profile, select it, and then paste. So we have entered the data for first day, and the display totals per value for day, it's coming to 30.21. That means our consumption for the first day is 30.21 kilowatt hours. Save it. Come back. Now let me select selection date 30/01/2020. Select the profile. Now let me go to select data for the second day. Select it and then paste. So the total value for the second day is coming to 33.63. So now save it. So now we have the data available for 29 to 30th. So 29/01/2020 to 30/01/2020. We have the continuous data available, and then on 29th we have got peak consumption as 0.63. That means among the 15 minutes consumption data, on the first day the peak consumption value is coming to 0.63, and on 30th the peak consumption is coming to 0.71. So between these two, for both the days put together, what is the peak consumption? It is 0.71. At one particular duration of 15 minutes, the consumption has been recorded as 0.71 kilowatt hour, which means what is the maximum demand? The maximum demand will be 0.71 into 4. That will be 2.84 kW. That means for both days, we have observed the peak demand which has come into the picture is 2.84 kW. And we have the consumption data for both the days. Now we will execute the billing document. Since we have the data in the profile, we will do the billing. Go to EASIBI. Our billing date is 30/01/2020, and our document date is 30/01/2020, and posting date 30/01/2020. Installation is 250, and then execute. Now individual bill is completed. There is no error. So we will say our billing document is 2332. Now let's go to installation and then find out the billing document. Then you can analyze how the RTP has worked. So go to billing periods and then go to the document 2332 is the billing document. Now totally there are 7 line items. Why 7 line items? Because in our rate we have got basically 4 lines. The first 3 lines will be for the statistical information on the quantity. That means how much is the on-peak quantity, how much is the mid-peak quantity, how much is the off-peak quantity. Then for each quantity, one value item, how much is on-peak amount, mid-peak amount, and the off-peak amount. Then the 7th item will be what is the demand value amount. Okay. So for the period 29/01/2022, 30/01, we have got billing quantity 20.45. And then if you take the item number 2, that is the on-peak price. So 20.45 kilowatt hour is total on-peak energy, and for that price is 15 rupees, and the amount is 381.75. Now we will go to the third line item, which is a mid-peak quantity. It's coming to 17.78, and then the mid-peak amount is coming to 213.36, and then we go to fifth line item, that is coming to 20.61 kilowatt hour, and then for that the amount is coming to 206.10. And then the 7th line item is coming to maximum peak. The maximum peak is coming to 2.84 kilowatt, and the price amount is basically 30.00. That's basically the price. So net amount is 170.40. So how the demand value has been calculated, we'll find out. Now first we will go to RTP analysis. In the particular scenario, our installation is basically having a smart meter. Because of the smart meter, the billing will happen through RTP. So how the RTP has worked here? Okay, we can do the analysis. So we will select the start analysis. First we will go to input parameter. Now input parameter, we have got the graph. That means what is the consumption which has happened. So generate the graphic. So here we can see how the consumption is happening for both the days put together. That means starting from the 29th of January midnight, okay, till 30th of January 11:45, we have got the consumption data, and that is displayed here according to our value what we have. Now among these 2 days, you can see there is one peak value. Okay, this is a peak consumption. Okay, this particular point is basically for peak consumption, which is coming to 0.71. Okay, if you see the data, it is coming to 0.71. So in our case, we have taken 0.71 into 4. Okay, so that means the peak consumption is coming as 0.71. Now we will come back and then go to again RTP analysis. Go to output parameters. Let's go to output parameter. Now in output parameter, what it is doing, we have used one formula copy 01. Now what is the job of copy 01? Based on the formula copy 01, it will create 2 output profiles. One will contain energy data as it is copied from the input profile. So another output profile will contain the demand values calculated for each interval. Okay. So let us select the output parameter, and then we are applying copy of the consumption profile and copy as the demand profile. So let's start analysis, select the graph and generate the graphic. So if you select the graphic, here you can see there are 2 curves. The one which is shown in the blue color is indicating the copy 01, the first output profile data. That is the energy data as it is, which is copied from the input profile. And that data is seen here in the blue color. Okay. And then here again, maximum peak is coming to 0.71. Okay. This is 0.71, which is coming. Now for each of the value, what is there in the input profile value, it has calculated the demand value, and each value is multiplied by 4, and then those values are available in the second output profile. And accordingly, the maximum demand which has come into the picture for both the days put together is coming to 2.84. Actually, it's coming to 2.84. That is a peak demand which has come. Now we will go to the resulting parameters. Resulting parameters means basically based on the RTP execution, it has used the two RTP components. The first RTP component is on-peak, mid-peak, off-peak component that will work on the first output profile, which is having the energy data copied as it is. On that particular data, the RTP component will divide the interval data into 3 time slots. The consumptions that have happened both the days during the on-peak period, and the consumptions that have happened during the mid-peak period, and the consumption that has happened in the off-peak period. And for all these consumptions, it will apply the sum as the function and then get the total value. So based on that, you can see the total on-peak quantity from 2901 to 3001 is 20.45, and then mid-peak quantity is going to be 17.78 and 20.61 for the off-peak. So that means in this particular Excel sheet, if you see whatever consumptions are happening from the period morning, midnight to next day, morning, afternoon, 11 o'clock. I think we have taken up to 1 o'clock as the consumption. That is up to here, you can say. This is the time zone up to which it has got all the on-peak data. For both the days put together, it will add up the data. Then it will get the on-peak. Likewise, starting from 1351, I think we have taken up to 17 hours. So this period, it will add up the data pertaining to mid-peak, and the rest of the values will be added for the off-peak. So in the particular calculation, you can see it has shown 3 display value, and then it has got one more value, that is a maximum demand. Okay, maximum demand is coming to 0.84, and for this also we can have the graphs seen here. So it is showing totally 4 graphs. The 4 graphs are basically for on-peak, mid-peak, off-peak, and the demand values. And among the demand values, it has taken the maximum demand coming into the picture as 0.84. So how the demand value will be calculated? The demand value is calculated, that is the power value. Okay, that is basically for the billing the demand value. So demand value amount will be equal to peak demand into what is the price, that is a time dependent price, and then what is the number of days for which you are doing the billing. In our case, the peak demand has come to 0.71 into 4, that is 2.84 kW, and our price for demand value, how much is the demand value price? So if you go to our pricing data, if you go to the line item number 7, okay, if you go to line item number 7, single lines, it is coming to 30 rupees. So 30 rupees per kW per day. 2.54 is the peak demand into 30 rupees per kW. This is rupees per kW. And then what is the number of days for which you are doing the billing? It is 2 days. So our demand value will come to 2.54 peak demand into the demand value price is 30 rupees per kW per day into 2 rupees. So that will come to 152 rupees 4 paise. So if you go to the value, it is coming to 170.40. So 2.84 is the quantity, 2.54, it is 2.84. So 2.84, that is the peak demand, 2.84 into 30 rupees per kW per day into 2 days. So it will come to 170.4. That is the value it has calculated. So using basically the demand price, it has calculated. So we can conclude how our process has happened here, how RTP has worked here, RTP working. In the case of RTP working, we have the input profile. Our input profile is basically 148, which is containing the consumption data for 2 days. And then this particular profile data has been used to generate two output profiles. One is the copy of kWh values as it is, and another is copy as the demand value. Copy as the demand value. So in this particular case, this will contain the same data as input data, input profile, and this will contain each interval data multiplied by 4, interval data into 4. And then based on that, the output profile has been created. Here we cannot see the output profile. It is created internally and then it is used in the calculation, but the data is displayed in the form of a curve, okay, so that we can understand the pattern of consumption and also the pattern of the demand. Now the first RTP component, okay, the first RTP component what we have has worked on this particular value, copy of the kilowatt hours, and then based on that it is applying time series 6001 on time. So on peak, you can say on peak. So it has taken all those consumption values which have happened during the on peak period and then sum it, okay, and then that will become the on peak quantity. Same thing will apply for 6002, the mid peak, and then 6003 is the off peak. So for all the three durations, we have got the data which is captured, and then it has got the sum data, and then based on that, it has calculated the on peak amount, on peak quantity, mid peak quantity, and off peak quantity, and the prices are applicable. Based on that, the amount has been calculated. Then the second RTP component has done basically found out what is the peak value. Okay, so the peak value is available. Based on peak value, we multiply with the demand price into number of days. Based on that, the demand value has been calculated. So basically here RTP component is crucial, and depending on the RTP component, our billing values will come. In some companies, they may take only on peak and then off peak. They may not have any mid peak. So they have got only two prices. So depending on that, when you create the RTP component, you can say I have got RTP component which has got basically two time series, on peak and off peak. Accordingly, some value will happen and the demand value will be calculated. Okay. So basically, we have seen how the RTP analysis is working, or how RTP is working, and then how the RTP components are helping us to get the values from the profile, and then based on that, we are doing prices amount for the three durations, on peak, mid peak, off peak. And for demand also, you got the maximum demand which is available from the profile, and the demand value also calculated. So now we will go to EA19 and then prepare the invoice. So the invoice is going to be 30/01/2020. Our posting date is 30/01/2020. And let us say reconciliation key is L1200, and our contract account is 5301. We will take it as 5301 and then execute. So the billing document is through 2332, for which invoice is prepared. Now we will see the print preview, how it will show the print preview. Go to display document. This is the total value for both the days put together, and then go to print preview. In the print preview, it will show all the 4 line items. Okay, it says for 2901 to 3001, the consumption is coming to 20.5 kWh for on peak, 17.8 for the mid peak, and 20.06 for the off peak. So 25.5 into 15, and then off peak, mid peak, and then demand is coming to 2.8 into 30 into 2 days. It will come to 170.40. This is the total amount what consumer has to pay. Okay, so the billing and invoicing will help us to identify the consumptions happening into 3 durations. Accordingly, the billing has been happened. Okay. Now, in our consideration here, we have worked with the what you call elementary profile. Okay, what is elementary profile? Elementary profile is a profile in which we could enter the data, and based on the data entry what we have done, the billing has happened. In the actual scenario, how we have the value entered in the profile, because we cannot go on entering for thousands of profiles manually for each day. The data will actually come from the AMI company in the form of the IDOC. Okay, so if you go to the EDM and then profile values and then monitoring, profile value import, EDMI1. So here date of import, IDOC number. Okay, that means we receive for each and every meter an IDOC. That IDOC will contain the continuous data for the number of days in the interval form of data. And we pick the IDOC numbers which have been received in the system. Based on that, automatically it will find out what are the profiles assigned to the each and every meter, and the data will be written to the meters actually. That means basically AMI company will send the IDOC. Basically, what is IDOC? IDOC is basically intermediary document. It's a data distribution system, how the data is sent between two systems. Usually any SAP system is a data distribution system. What is the meaning of data distribution system? As a SAP system can send and receive the data from another SAP system or another system. That means SAP can send and receive the data with another SAP system, or it can also send and receive the data with other systems which are not necessarily SAP. So the AMI company is not having SAP. It is having its own platform, it's having its own data, but the data exchange is happening between these two. The AMI company will send the data to SAP system. So usually the data what is received, it will be in the form of a IDOC. Data is in IDOC. Now the process will be AMI company will trigger the data. AMI company sends the data, and this data will go to a EDI subsystem. It will go to EDI subsystem. It is basically the place where it will convert the data from non-SAP to SAP format. That means our database is different and the AMI company database is different because they are not using SAP. So the data definition, data table, everything will be different. But when the data is going to be put into SAP system, it has to be available in the format required to be filled up in the database tables. So for that purpose, the EDI subsystem will come into picture. This EDI subsystem is basically called PI system, process integration system. Okay, basically earlier we had SAP XI, Exchange Infrastructure. That was the EDI subsystem. They made it to PI. So PI system is the one which is basically acting as a converter. It is converting the data from non-SAP format to SAP format. After the conversion is done, it will basically generate an IDOC, and this IDOC will be sent to SAP system. And once SAP system receives the IDOC, they can be read into the profile and importing of the data can happen. This is one method. Or you can use any other method, like you can use BAPI, Business Application Programming Interface. So various methods could be possible with which the data could be entered into the system. Okay. Now, coming back to our profile management, so far we have used a actual interval meter, which is having the actual real consumption data recorded for the 15 minutes. But apart from the elementary profile, what are the other profiles we can work? Broadly speaking, there are 4 types of profiles. The elementary profile, then you've got synthetic profile, day profile, and formula profile, and then we have got what you call the integral profile. Now, in the particular scenario, 148 profile, what you created is the elementary profile, because in that profile, you could enter the data. If required, you can change it, and then accordingly, the value will be built. Now, there is one more additional configuration is there, which is not actually working in our system because of some missing patch or something. It's called the value adjustment. Okay, that is, if you go to our EDM and then go to profile header, and then display. Our profile is 148. When you created the profile header level data, we have got here a ref value group. Okay, it's called ref value group. What is the job of this group? When the data is imported while building, what should happen? For every interval, data should be there. Okay, even if let us assume 115 minutes value is missing from the profile, we cannot do the billing. System will throw the error. There's no value. Now, actually, during on time, what happens when the data is imported? Sometimes some values will be missing. Okay, that means maybe the data has not come from the EMI company, and as a result, the particular interval data is missing. Okay, so in that case, how the billing can happen? So this ref value adjustment group, what it will do, it will use some kind of inbuilt extrapolation and interpolation. Based on the missing value, it will generate the value to be added to interval data. That means, let us say, for example, we have got data at 10:15, we have got data at 10:30, we have got data at 10:45, but 11 o'clock is missing. Okay, 11 o'clock is missing. And 12 o'clock, 11:15, we have the data. So system will automatically, it will substitute the value for 11 o'clock based on the interpolation. That means if sufficient values are available before that, or if sufficient values are available for the period after that, taking into consideration of them, it will compute what should be the data for 11 o'clock. That means automatically system will write the data for this particular missing value. That means during the billing, it is ensuring that we have got the values for all the profile intervals. Okay, that is basically a REV group particular functionality. Okay, but in our system it is not working because of some patch problem, but otherwise it can be done. Okay, now coming back to the profile management, after having worked with the Elementor profile, we'll be starting now to work on the other profiles. Okay, so we will start working now on the second type of profile, which is called synthetic profile. Now, let me explain today just a concept so that you can start working on the actual profile. Now, what is synthetic profile? Synthetic profiles are used only when we don't have the smart meter. If you have a smart meter, that means you have the actual consumption data and we have it in the profile. We have assigned the profile to the meter and the billing will happen. The synthetic profiles are used in those cases where we have no smart meter, but we want to generate the data for the analysis purpose and also for the correspondence purpose to the values for the particular installation. Let's say you got one installation as 250. It has got a standard meter, which is, let us say, 451 is a regular meter. This meter, we are doing the meter reading once in a month. Like a conventional meter, we have done the meter reading, and the consumption has come to 900 kilowatt hour. Okay. Based on this, billing will happen. We have got the prices for the consumption value, billing will happen. So as far as the consumer billing is concerned, it will happen based on the actual meter, which is a regular conventional meter, billing will happen. But this 900 kilowatt hour, which is for the total duration of 30 days, we want to have this data split into 15 minutes interval data. We want to have 15 minutes interval data. For each day, for each 15 minutes, we want the data. How to get it? Okay. Now, if you had a smart meter, data would have been available, but smart meter is not there. But we want this data to be available. How to have this data generated? That means based on this 900 kilowatt hour, I must be able to generate the data for each and every 15 minutes, and then that data should be used for some other purpose, not for billing. If we have data like this for each and every installation, we can add up them together by the end of the month and send the consolidated data to the generating company. This is how the interval data has been consumed in our distribution area for all the installations put together. So in such cases, we basically go for what is called a load profile. And that load profile is nothing but a synthetic profile. Synthetic profile means when you create a synthetic profile, unlike Elementor profile, we cannot enter any data. In the Elementor profile, we could go and enter the data. But in the case of synthetic profile, we have to generate the data. The data has to be generated. This data generated will be based on the day profile. That means you cannot work with only synthetic profile. If you want to make use of synthetic profile, you also have to have the day profile. Now, what is the concept of day profile? A day profile contains the value for exactly 24 hours or 1 day. One day only containing data for 1 hour. 1 day. 1 day. It cannot have more than 1 day. So, in the particular scenario, what the energy company will do, they will use the actual smart meter. Okay, put it in a sample installation. Let's say typical 2-bedroom apartment in a particular region, and then when you put this smart meter, they will record the actual consumption based on the smart meter for one particular day, and the number of days can depend on how you want the data to be collected. So you can say our year is divided into summer season and then winter season. We use the season group here.
The season group here.
Summer and winter. And for summer, we will say there are 2 days.
The 2 days. That is the working day
and holiday or non-working day or weekend. We can say weekday and then weekend. Weekday and weekend. And then winter will also have 2-day profiles. That is weekday and then weekend. Weekend. So we have the actual data collected for the weekday and weekend for summer, and winter weekday and winter weekend. So that means we have got the profiles, 4-day profiles. In 4-day profiles, we put the actual data collected from a smart meter. And once the data is available in these day profiles, we generate the data. In the case of synthetic profile, for the whole year. For the whole year, we can create for each and every year. We can create for 2019, 2020, 2021. Okay. Now, this synthetic profile is for a sample installation. That means it is not for one particular installation. It is for all the 2-bedroom apartments installations. The profile is created, and this profile will be assigned to installation. This profile will be assigned to installation. So if you have seen any installation so far, you have a particular field over there. If you go to ES31, if we take our first installation, it's basically in non-interval meter, regular meter. So here you can see load profile. There's something called load profile. So if you select the load profile here, we can assign the synthetic profile. So each and every installation, which is a 2-bedroom apartment, a synthetic profile is assigned. That means all the installations will have the same synthetic profile and same data. Let's say for each of these synthetic profile, we have a integral profile based on which you come to know what is the, according to synthetic profile, what would have been the consumption. Let's say there are 3 installations. Installation 140, installation 150, installation 160. All are having regular meters for which you assigned one synthetic profile, which is 170 is a synthetic profile. That means the data is same for all the profiles. Okay. And based on synthetic profile, we come to know what should have been the consumption value for each of these installation. So let us say it is coming to 1000. In a month, it's coming to 1000. But actual consumption has been entered for each meter. In one case, it is 970. In one case, it is 1020. In one case, it is 850. These are the actual consumption. Now what system will do? It will calculate the ratio. According to actual meter, it is 970, but according to synthetic profile, it is 1070. So here you got a factor 0.97. This 0.97 will be multiplied with all the values which are there in the synthetic profile. Based on that, we come to know the interval data. It's not actual interval data in the sense there's no real meter, but more or less it is very much in line with the consumption pattern. So multiply 0.97 with the synthetic profile value, what is assigned to the installation, and the values are generated for complete duration for 15 minutes. And here it is 1020 divided by 1000. So the multiplication factor will be 1.02, and in other case it will be 0.85. That means based on synthetic profile, we come to know the multiplication factor based on the each month meter readings, and then they will be multiplying with the synthetic profile value and then create a profile data, which is basically like a smart meter data. Then when you add up all these profile values, you'll come to know 15 minutes duration for the entire region. And this profile data will be sent to the generating company. So for that purpose, we are using the sensitive profile. So we will see how to use it in the tomorrow session. But sensitive profiles are not used for billing purpose. They are only used for correspondence, basically for splitting the consumption value recorded as per the regular meter into a kind of synthetic data. Now, it is not 100% matching. I mean, it's not actual 100% real-time data for a smart meter, but it is very much near to what would have happened if you use a smart meter. So this is the concept they use for the synthetic profile. So we will see how to create a synthetic profile, how to create day profiles, how to connect them, and how to add the values into day profile, and then generate the synthetic profile. And then we will see how to assign a synthetic profile to a meter and how the billing ratio will be calculated. The not billing ratio, the ratio between the actual consumption data with the synthetic profile. And then based on that, the system should be able to use in the future the interval data for the installation. So synthetic profiles are assigned to n number of installations, whereas actual elemental profile is assigned to regular meter into smart meter. If you don't have smart meter, then only you'll go for the synthetic profile. Again, it is left to the company. If they're not using synthetic profile, then they will use the regular data only for settlement purpose. So tomorrow we will see how to do the synthetic profile. After that, we will see how to do the formula profile, okay, the third category of profile. And integral profile will come along with the synthetic profile. So by that time, we would have covered all the types of profiles. Okay.
Hello.
Hello.
Yes, sir.
Yeah. Please, any doubt?
Yeah, no doubt, sir. Small request.
Yeah.
In the post completion of all these things,
Yeah.
can we dedicate 2-3 classes
Uh-huh.
specifically for? Hello.
Hello. Yeah. I'm listening. Yeah.
Yeah.
Hello.
So post completion. Yes.
Uh-huh.
Yes. Post completion.
Yeah. Sure.
3 classes
Uh-huh.
for this rate which we have created,
Uh-huh.
and what we have done is very simple one for the normal meter.
Yeah.
We use a simple formula quantity 01 and calculated it.
Yeah.
But in the real business scenario,
Uh-huh.
there are multiple permutation and combinations.
Mm-hmm.
So it would be good, sir, if we actually take in features as well
Yeah.
for calculating the overall bill, at
Yeah.
least for 1 or 2 consumers, so
Yeah.
that we'll be in the position as far
Yeah.
as the interview or anything is concerned.
Yeah. No, we are going to work some more scenario. Our billing and invoicing still not over. We are going to do device rental value. We are going to calculate the demand values. We are going to calculate the street light, then discounts and surcharges. So many are coming. So whatever is given in the course content, it is in the consideration of the real-time requirements. But we haven't done that. We are going to do that in the future. So by that time, we would have covered everything, whatever one needs to know.
Say, for example, sir, there's one scenario which we generally face in our DISCOM, is that we have a recorded demand, that is a contract demand, which the consumer applied for and taking the connectivity. So, say, for example, 1 kilowatt. Now, but for each and every consumer, but when we try to record the billing of that consumer, we take a maximum demand of that consumer. So in case recorded demand is greater than, say for example, recorded demand is greater than maximum demand, then the consumer will build on recorded demand. Then that is okay. But if the maximum demand is greater than recorded demand, then 2 circumstances arise. If it is greater than 110%, 1.10, then it is that the consumer is charged for that additional part on, for example, 1.5 times. If it is less 110%, but greater than the recorded demand, then
Mhm.
it is charged that on the same amount.
Okay.
So then that comes two scenarios.
Yeah, yeah.
Third is if less than 0.85,
Mm-hmm.
less than 85%,
Mm-hmm.
then we give them a rebate of, say, for example, 1%.
Okay. That is basically
Okay.
discount. So
Yes. Then there
discount.
is discount as well as charges, as well as
Okay.
additional excess demand charge.
Okay.
We
Okay.
charge that excess demand charge.
Mm-hmm.
That is which is very means the remaining thing is fine. The flat rate is there, the prices are there. That is okay. But then the demand part,
Mm-hmm.
there can be multiple scenarios,
Okay.
not one.
We
or two.
will
There
we
can
will
be
see. We will see what best you can see show in the system.
Yes.
I'll definitely show it. No problem. I'll do
Yes, sir. Because we use certain if condition also in
Yeah,
there,
yeah.
else condition
Yeah.
also is being used.
Actually, I did not work on the if condition. Without if condition, whatever possible, I'll show it to you. No problem.
Okay. So if condition is not possible to be
No,
shown.
not possible. No, not possible.
Okay, sir.
Okay.
Any specific reason for that, sir? This
No,
if
I didn't
condition.
work. I didn't work on that. So that's the reason I'll not be able to explain. So without if condition,
But in
Hmm?
general, sir, it's a general question. In the general utilities that you have worked with or you have had experience with,
Mhm.
do people use this if condition in large scale or it is not being used?
Actually, if you see in the real time, they will create a rate containing even variant programs which are not standard variant. That means we are using
Yes.
standard variant program. There could be a lot of scenario which are having non-standard variant program. So in the project, it is okay because there we can spend time to work out all the details and do it. But in the training program,
The G program.
in the training program, it is difficult. So our training program is designed to give you the basic foundation. Okay, but tomorrow when you start working in the project, then you have resources and everything. You can work it out. But in general, you will get the idea from the training how a basic structure is working. Okay, otherwise in the device management itself, if you take real-time scenario, we require so many days of training to be done, but it is not actually feasible in the duration. So, but the training program will give you the basic structure, but depending on your scenario, you will be able to pick it up when you do it in the project.
And who creates this variant program? This is this a
ABAP.
job of a
ABAP.
ABAP?
Yeah, it's a
And
system
one small thing,
modification.
sir.
Yeah.
Yes, one small thing, sir. If it is possible to just throw some light on, say, for example, that the functional document that generally is made for that the live project.
Yeah.
So, means just overview that how the functional document is exactly.
That I explain.
What
No
are
issue.
the conditions to be included in the functional document? How can we get the detail about certain tables? And make it in a document so that the ABAPer or the developer can use it.
Yeah, sure.
So that I think that would also be a job of the ISU consultant.
Yeah. We'll see how normally a functional document should be written. Again, there's no specific format. It can vary from company to company. But in general,
yes, sir.
I will explain.
Yes.
No problem. Sure.
In general, with the program and all those basic things.
Sure. No problem. We'll do that.
Okay, sir.
Okay.
Thank you.
Thank you. Yeah. Bye.